Hello everyone. In this video, we'll today understand what is clustering, what is the purpose of clustering, in clustering what we do, and what kind of methods we can use in clustering, and what are the applications of clustering. Then, first of all, what is clustering? The task of grouping data points based on their similarity with each other is called clustering. This method is defined under the branch of unsupervised learning, which aims at gaining insights from the unlabeled data points. Unlike the supervised learning, we don't have target variable here. Clustering aims at forming groups of homogeneous data points from a heterogeneous data set. It evaluates the similarity based on matrices like Euclidean distance, cosine similarity, Manhattan distance, and etc. And then group the points with the highest similarity score, in which we have multiple data points, or we can say we have the heterogeneous data sets in which we picks up the similar data points, and then group them together. So as you can see in the graph as well, this black dots, as you can see in the picture, is the data points from the heterogeneous data sets, and we have grouped them together on based on their similarity score. So you can see just what is the purpose of this picture here is, as you can understand, the groups we always form, or the cluster is not always of the same shape or have a defined shape, which can be in the sphere shape, or we have no shape here. So yes. Then we have types of clustering. We have two types of clustering here, hard clustering and soft clustering. In hard clustering, each point belongs to a cluster completely or not. In the soft clustering, on the other hand, instead of assigning each data point into a separate cluster, a probability or likelihood of that point in the cluster is considered. Then what is the steps of clustering? Let's understand that. We have first step is the initialization, where we initializes the k. K is the number of centroids, or we can say the number of cluster we want to make. Then we have the assignment step. Then for every nearest point we calculate the score based on the Euclidean distance or the Manhattan distance formula. Then the third is update step, in which the we compute the new centroid for each cluster. Then we will iterate the step until the convergence. Then you can see in the both snippet there is a clustering code. We have used the k-mean clustering, which again based on the nearest point of the data sets. We have used the NumPy, Pandas, scikit-learn's cluster. We are using the k-means here. Then we are using the data set, which is the iris data sets, which is the most one of the popular data sets. Then we are using the pre-processing, in which we are transform the model using the standard scaler. Then we are using the matplotlib for the visualization of clusters, and seaborn also for the visualization of clusters. Then first we load the data, we are load the iris data into the data variable. We have created the data frame out of it. Then we have transform our data frame using the standard scalar fit transform function. Then we have applied the k-means here, in which we in the parameter we have given the n cluster value is equals to 3, in which we want to make the 3 cluster, and the random state, which means it will repeat again and again for every data point. Then we have fit the data, obviously whatever the answer is we have. Then we have plotted the data points for the visualization and better understanding. You can also use this snippets in your IDE, and then you will get this kind of result on your in the output, in which you can see we have three multiple colored dots, and every colored dot is nearby each other, making a cluster. Like yellow dot is will be on your left side, and then your the purple one is your right side, and the green one is your left upper side. So these is separated. We can see visually the three clusters are differentiable. So yes. Then what are the application of k-means is the customer segmentation, like what kind of customers. For example, in a DMart, that how much customers are buying that Sachi doodh, and how many customers are buying the Amul products. So we can use k-means cluster based on that, how much people are liking the Sachi products and how much people are liking the Amul products. So according to that, we'll restock our stuff, or we'll change some on the sales part. Then we have the image compression. Then we have document clustering, in which we can cluster or group the similar kind of documents for our feasibility. Then we have anomaly detection. So I hope in this video, in this short video, you have got a good understanding of what is clustering and what are the applications of it. And we have also seen the code snippets for the coding part as well. So thank you.